So the first session we'll be starting with. So the first session will be on the sustainability assessment of life cycle thinking being delivered by Professor Brajesh Kumar Dubey. Dr. Dubey is a chairperson of School of Water Resources, professor in Department of Civil Engineering, and in charge of CERT in Indian Institute of Technology, Kharagpur. Dr. Dubey received PhD in Environmental Engineering Sciences from University of Florida, USA. He received Outstanding International Student Award from the University of Florida during his PhD program. And he has received his BTech honors in Civil Engineering from IIT Kharagpur. Dr. Dubey has over 21 years of research, teaching, and consulting experiences within the broad fields of environment, sustainable resilient engineering, and circular economy approaches, addressing the nexus among sustainability, resiliency, infrastructure, waste, energy, and environment. His research expertise include life cycle assessment, techno-economic assessment of engineering and next generation technologies, resource recovery, sustainability design, and the list goes on. He has worked with different international organizations like OECD, WHO, and has developed a lot of solutions in the domain of waste sector. Prior to PhD, he has 4 years of industry experience as a civil and environmental engineering in the area of petrochemical refineries and offshore oil platforms. Now we'd like to invite Professor Brajesh Kumar Dubey to deliver his keynote.
Okay, so good morning to all of you who are here and also many participants who are online. So we are, as probably you may have realized, that as per schedule, we are slightly ahead of the schedule, which usually doesn't happen in Indian context. But we have kept a little bit of cushion in between. So that's why we are a bit ahead of our schedule. So that gives me some time to go a little bit slow. So I think this session goes up to 1 p.m. So it's right now at, we are at 10:50. So we have like 2 hours, 10 minutes. So, but what we'll do is I'll not talk for 2 hours, 10 minutes. So I'll maybe an hour and a half, and then we'll open it for questions and answers. So those of you in the online platform, you can start putting your questions on the chat, and then we will collate all the questions and we'll try to answer. So please go ahead and start doing that, and so that it becomes easy for us. And you can later on you can unmute and ask as well, but it will be always better if you put it in chat. It's good for other people to see the questions too. So as there was mentioned in the beginning, during the introduction, Dr. Ravi Shankar, who is from our research group, presently working in engineering college in Andhra Pradesh, and he talked about that like we have been working on circular engineering research in this particular institute. So when we call circular engineering, that is actually a relatively newer term. It's people say circular economy. So we thought that how you can make circular economy without having circular engineering. So you need to have engineering solutions, then only circular economy will come in picture. So that's what the whole thought. And then of course it becomes a catchy. Right? It's a catchy word, so people grab attention. They have not seen before what is circular engineering. So it becomes easy for our group to kind of talk a lot of things associated with circular engineering, and gives a little bit of there is a little bit of excitement there as well. So coming to the topic, and some of you may have, those of you who follow me on different webinars that I do, you may have seen some of these slides before as well. But that's, I think, should be okay. Let's see. I think it works from here. Yes. So when we talk about all this sustainability, this is this whole concept of decarbonization today. So decarbonization is essentially what we are trying. Essentially, what it means, that decarbonization, as the word suggests, is that we are trying to reduce carbon. Isn't that's the whole purpose? Reducing the carbon. So is audio okay? Or audio is fine. Yeah. Okay. So in terms of when we say decarbonization, means trying to remove carbon, isn't it? That's what when we talk about decarbonization, it is essentially to remove carbon. So why we are trying to remove carbon? What is the whole purpose of trying to remove carbon? So essentially, what is the big picture goal? The big picture goal is to try to keep this planet as clean as possible. isn't it? That's so that our future generation should be able to enjoy the same kind of lifestyle, or they should enjoy better than us. That's the whole purpose. Right? That's the whole, like, as you will always want your children to have better life than you, and your grandchildren to have even better life than your children. So, but unfortunately, what has happened is that we have used so much of resources, we have created so much of waste, especially in last, say, couple of centuries, last few decades, but to be more precise, we are producing a lot of carbon, which is getting into the atmosphere, and that's creating a huge problem in terms of global warming, climate change of weather patterns, extreme weather patterns. This time of the year, we are talking to you from sitting at Kharagpur, IIT Kharagpur campus. We never witnessed this kind of heat wave that we are witnessing in last couple of weeks. And even today, now it looks like monsoon is almost there. It's still not here yet, but almost reaching here. So we have since in last, I would say 10, 15 years, we are seeing a very significant change in terms of weather pattern in this particular area. We used to get a lot of rain in the afternoon. Every summer days when it will be hot in the morning, we'll get rain in the afternoon. That was called Kal Baisakhi in West Bengal. In the month of Baisakh, we'll start seeing that. But no Kal Baisakhi these days. We don't get Kal Baisakhi. This time, that even negatively impacted crop production. Many mangoes which used to be bigger is actually much smaller this year because of they did not get enough rain to grow properly. So those issues are there. So when we talk about this Mother Earth, if you look at the age of this Earth, isn't it? When we talk about other Earth, let's look at the historic, historically the age of this Earth. Earth is said to be around 4.6 billion years old. There are some newer research which suggests that Earth is even older than that, but we will not worry too much about that aspect. Let's say that it is 4.6 billion years old. Now, in that 4.6 billion, if you take that 4.6 billion and put it in a 24-hour scale. Why 24 hours? Because 24 hours becomes convenient for us, so we can relate to 24 hours. Every day 24 hours is what we live every day. So if you put in 24 hours, 1 second becomes 52,000 years. So we're talking about that scale. 1 second is your 52,000 years. Now, if you take that and if you look at on your right-hand side, the timeline that you are looking at there is starting from very beginning in terms of the bombardment, and then you have your some of Earth and other planets, they collide, debris are being formed, and then there is not much activity for almost after 17, 18 hours. This is kind of following the railway timetable where we go from 1 to 24. After 12 becomes 13, 14, 15. So up to 18 means evening 6 p.m. Until evening 6 p.m. you don't see a lot of activities, but after 6 p.m. you see that first plant life, algae is there, then fish is there, different species started coming up, and a lot of life comes to this particular planet. And if you think about one of the bigger species that we get so fascinated about, the dinosaurs. So on this 24-hour scale, the first dinosaur appears at 22:47 hours. 22:47 hours, which is what? 1 hour, 13 minutes before. So if you think about that scale, means 1 hour, 13 minutes before dinosaurs were actually roaming around in this particular campus, which is, if you think about it in that particular scale. And they disappeared, and the dinosaurs disappeared at 23:40, which is, that's like not 1 hour, that's around 20 minutes before. So 20 minutes before dinosaurs were gone. So when we humans actually have come into existence at 23:59:12, that means 48 seconds. 48 seconds is that what we humans have actually existed on this planet, if you put the things in a 24-hour scale. And that's include our prehistoric, like not only the Homo sapiens, but even before species there. if you think about the modern humans, like the way we are, we have actually come into existence at 23:59:56. So that means only 4 seconds. 4 seconds multiplied by 52,000 years. So that's 200,000 years, slightly more than 200,000 years. So we have been on this planet for just 200,000 years. The planet is 4.6 billion years old. So Mother Earth actually does not need us. Like there were a lot of species before us, and there could be a lot of species after us. The COVID lockdown, when most of us were indoors, we saw the flora, fauna flourishing, wildlife flourishing, with more snakes on campus, roaming around freely. And that was that should actually how it should be. In fact, that is what it should be. Especially if you're talking about IIT Kharagpur campus here, it is the house of snakes. I say that we are illegal occupants here. It is their house, and we have taken over their house, and then now we are trying to force them away from this particular house. So that's not how the planet was designed. What I'm trying to say, the way the humans are actually working, that's not the way the planet was designed. So there could be time that as dinosaurs could disappear, and humans can also disappear. That can also be possible. That tomorrow maybe some more smarter version of us may be out there. So it says that we are the smartest species so far on this planet. Tomorrow there could be a smarter one, because as the evolution happens, anything can take place. But as of now, we have only one planet, and I don't think even if we are going to go away in 1 second, that is 52,000 years. So that's 52,000 years. At least we are here for. At least for a few seconds, we are here in this time scale. So next 200,000, 100,000 scale, I don't think, but we will have a lot of hardship if we keep on doing the business as usual. If the temperature keeps on increasing like that, things are becoming so unbearable. The heat and a lot of different types of disease that people are getting into. Just but yesterday there was today morning from last night there is a news flashing that many deaths in a district in UP, which you may have seen that on the newspaper. We don't know yet, but some doctors are suggesting that it was possibly because of some heat wave, or could be possibly because of, there are two theories going on. One is the heat wave theory. The other theory is possible water contamination. Water contamination, because as the temperature is rising, the groundwater levels are going down. People are trying to get water from wherever and whenever they can find, and that it could be possible that it was a contaminated water which created so much of problem. And also, I think close to 35-40 people have passed away over a period of 1.5 to 2 weeks. And it's very mysterious kind of disease. People are getting a lot of chest pain and then they are passing away. So it's really, we have to. So those are all because of the pollution that we are creating. And this decarbonization is essentially to try to look at how to reduce the pollution. That's the big picture goal here, to reduce the pollution. When we say decarbonization, it doesn't only mean that removing the carbon. Even if you are going for like some other initiative which helps into making the things better for the planet, that also is good. So what does that happen? If you look at the historically, this is our population data. Starting from BC, like 5,000 BC, all the way to 2023 AD, if you look at, and global population on the y-axis, so it's in millions. The scale is in million. That's why you see a very flat line until almost 0 AD. You see a close to flat line, and then we see a sharp increase in population. And part of it is because of course, our growth, our rate of growth went up, our like death figures went down. Earlier, our forefathers, 3-4 generations ago, if somebody has lived to my age, where I'm like 45 plus, that was like an old age. Like people were not, life expectancy was 40 and below, just 150, 200 years. People were not used to live very long. Very few people used to live in a longer life because of sometimes hija will be there, like cholera or some sort of disease will come, and villages after villages will get wiped out. But now, because of we have better medicine facility, better management in terms of water and all that, that's what we have in terms of water quality. We have been cautious about that. So we see that things are better. But the way we are creating so much of pollution, things may not remain better for a long time. So, and over last, as you can see, the huge increase in population. There's a sharp increase in population in last 200 years. From 1800s onwards, almost the population is going straight up. It's even kind of more than exponential. Like it almost looks like the graph looks like even higher than exponential curve. So it's like a huge increase in population. Right now, our rate of growth has gone down in population wise, but since our baseline is so high, still we have already crossed 8 billion. We will be reaching around 11 billion at the end of this century. So 8 billion, we are facing so much of a problem. Think about 11 billion, what will happen? So 11 billion people, we have to feed 11 billion people. Now, all those housing and all those air conditioners, if the way it is happening, if we put more, every year people keep on adding a lot of air conditioners in every summer. We see a lot of air conditioners getting added to the houses in our country, around the world, wherever. And then they also generate a lot of heat. Then we complain that heat is going up. Then again AC comes. So it's a vicious cycle. It's a vicious cycle which keeps on going on. But that's one part of it. But another part is, which is one of the major part, is our transport sector. This project, which is more focused on transport sector, as during the inaugural program, Dr. Puna was also mentioning the transport sector. We have some data on that, as he was referring to. I have some data, and I think Ravi will talk about that in more detail in terms of carbon from different sectors. So it's like a major source of carbon release into the atmosphere is from our transport sector. So how to decarbonize the transport sector? Now, and as increase in population, right now, actually in India, only around 12% of the household has a car. Only 12% of the household has car in India. And that's the government data of last, based on the vehicle registration and all that. And some household may have more than one car, but around 12% of the household has car. And think about that, if that number goes to 20%, 25%, what will happen to our road? What will happen to all the emissions coming out? Can we really afford to have that kind of like a transport system? Should we move to some other kind of transport system? Should we look at our public transport in more close scrutiny of public transport, reliable public transport, something like what our Mumbai local used to be. Even today, it is more or less reliable, but it's too crowded now. It's very difficult to get into Mumbai local, especially if you're not from Mumbai. You need a special trick, like a special training to get into that local and come out of that local. So it's so those like, but can we have a more better public transport system, reliable public transport system with a last mile connectivity as well? That is another problem with the public transport. We have metros, but how to get from my house to the metro? That connectivity is not there, or from the metro station to my office. So those connectivity is also required. That's called last mile connectivity. So if we have to kind of look at that, otherwise with so much of demand for resources in terms of different products that we make, different transportation system that we have to develop, we will see huge increase in carbon emissions. And negative impact of that carbon emissions is we all are feeling. This summer was kind of a big, you can say, eye-opener. This is the warmest June in recent decades in terms of in global temperature. So this is the warmest June so far. So that's a very big deal. So increase in population, more and more people going into the urban areas. People are moving from the rural areas to urban areas. That is also adding a lot of stress. More people in urban area, more water demand in that area. You have to supply it clean drinking water. You have to treat the sewage. You have to collect the sewage, treat the sewage. More transport requirement for people moving around. So 1900s, we have 2 out of every 10 people lived in urban area. By 2030, it will be 60%, from 20% to 60%. And as you can see, every few, it's going to, and by 2050, 7 out of every 10 people will be in urban areas. Urban areas, space is limited. We get a lot of slum areas. That again creates a lot of problem. Your slum areas has a lot of negative like impact on the environment as well. So this makes things very complex. So along this different issues, that these are some of the snapshot issues. We do have some, there are certain, those of you who have more interest in this particular sector, we do have several videos available on YouTube where we talk about these in great detail as part of our environmental science course, EVS course that is out there. And we do talk about even as the EVS course that we teach at IIT Kharagpur. Also, we have several slides going into great detail about each and every aspect that I have talked about so far. But whenever we looked at these, what we were talking about, what is the kind of what is the problem out there? Now, once you have a problem, you have to try to quantify that problem, isn't it? First, we have to understand what is the extent of the problem. Then only you will be able to design something. Like, for example, as a civil engineer, as a structural engineer, even if I want to design this building, I need to know what is the load. What is the load that building will take, so that I can have beams and columns and all those things designed, so the reinforcement and other things has to be designed. So similarly here, we have to know in terms of what is the extent of the problem. When we say impact, what is the quantification of that? And then when we talk about this decarbonization, we try to reduce with the newer measures to decarbonize. We should also be able to find out what is the benefit. So you move from regular vehicle to electric vehicle. Okay, very good. But what is the real benefit of when you move from like a regular, say, diesel-driven vehicle or petrol-driven vehicle to electric vehicle? How much carbon you are really saving? How much carbon environmental impact you are really reducing? So those, before you get to that, you need to kind of understand what is the impact. So impact has been different. This is a very basic industrial ecology equation, where impact is population times affluence times technology. It's our population times affluence times technology. Population globally, including in India, is going up, and we cannot, we don't have, of course, there are some control over that, but still, we will see an increase in population because our baseline is high, although our growth, population growth rate is coming down. But we will have higher population, like the population will keep on increasing. So we cannot, in terms of this impact equation, population will go up, at least in the near decades. We cannot there is no way we can make it down. Then the other thing is affluence. Affluence, you can say maybe GDP per capita. That kind of a measure of affluence. Now, affluence, we want it to go up, isn't it? We want people to have better lifestyle. We want people to have more money. So we do want people to have to be more affluent. So affluence we want it to go up. So what is left with then? There is only thing left is technology. Now, if I want to keep the impact as it is, whatever is today, but my goal is actually to reduce the impact. Now, if I have to reduce the impact, population and affluence, it will either go up or population may be stable. Affluence, we want it to go up. So only thing left is how to reduce the negative impact of the technology. That only can help us to make the impact stay constant, or if possible, take it down. What the researchers and modelers are suggesting, that IPCC document, Intergovernmental Panel for Climate Change, that document is suggesting that 1.5 to reduce our, we need to actually maybe work more than that. But even for 1.5 degrees centigrade to keep it the impact less, only thing that we can work on is the technology. And that's where the role of engineers and scientists and these things comes in very, very important in terms of how to reduce the negative impact of technology. So those of us, if you are in the audience, online or offline, those of you who are doing research and other stuff, you should always think of that. Research, we should not do for the sake of doing research. Just not for publication. Publication is important, but at the same time, what is the social, how it is going to solve this problem? This is because this is a bigger problem. We are all working in the technology domain, directly, indirectly. So how can we come up with technology which will have the lesser environmental footprint so that the impact will be less? So that's it's very, very important. As you can see over here, in this particular slide, what has been shown is that if you take the entire globe, you can predominantly divide it into three broad categories, like biogeophysical system, natural resources, and biodiversity. And all those natural resources means your water, your minerals, your fossil fuels, land productivity, pollution, manufactured products, and all that. Biogeophysical system is, of course, your atmosphere, climate, nitrogen cycle, carbon cycle, phosphorus, iron, all those different cycles. Biodiversity is your mass extinction, biodiversity loss, you have invasive species coming in. So these are all different aspects. And these are not, this is not an exhaustive list. This is some of those examples which is out there. Now, all of them has been put in red. The reason for that is all these aspects has been already impacted in a negative way since 1800s onward. Before that, like I used actually in my EVS class, if you look at, I have 3 slides for this. It's like a prehistoric, then in between, and then some of them are blue, some of them are red. But in if you look at the recent 200 years, we have in fact impacted pretty much each and every aspect of these 3 systems in a negative way. When we are saying in water, we are using too much of minerals, too much of fossil fuels, land productivity has gone down, produced too much of fertilizers, pollution, and then same thing with the physical as well as many species. Every day we are losing species. Every day we are losing some species or other. See, every species on this particular planet is there for a reason, is there to actually help the life on this particular planet. If all the species are gone, we cannot survive. If all the honeybee is gone, we don't have food. We don't realize that, but see, we keep on using some fertilizers which are very bad for honeybees. But if we keep on using those fertilizers, yes, if we keep on using those fertilizers and then the honeybees are gone, that will create a lot of like a negative impact on on our agricultural productivity, on our all the like a day-to-day, even all the food products that we have. Okay, what was this one? Okay. So coming to more closer to this particular topic on transportation. So there are a lot of, there is some global CO2 emissions from the transport, as Professor Kuna was mentioning in the beginning as well. So based on the global transport emissions in 2018, which total around 8 billion tons of CO2, transport accounts for nearly 24% of the CO2 emissions. That's the reason why this ITF and Niti Aayog and other organizations have come together, and they are trying to look at how to reduce the carbon footprint in the transportation sector, because transportation sector is around 24%. Waste management is around 11%. Waste management is around 11% of emissions coming from the waste management, including open dumps, waste to energy, and all those different plants that we have. So out of those 24%, out of that 25% total, nearly 75% is actually coming from the road vehicle. 75% is actually coming from road vehicle. That's the reason why like if this particular project is focusing on different transport fuels for the road vehicle. So road passengers is in 45%, freight around 30%, then you have aviation, which is 12%, and shipping is around 11%. So that's what in terms of coming from your vehicles. And if you look at in terms of, and you will get more details on this, I think later on when Ravi will be presenting. So I'll not go in great detail. I don't want to kind of take away all the discussion that he wants to have, but I'll just summarize it here, and then Ravi will go in more details later on. That we see that passenger cars are a major component in terms of emissions coming out. Then if you try to look at in terms of what is your carbon footprint from a flight to the car to all those different types of flights, you can calculate your from elevators to taking a ferry to the rail to electric vehicle or gasoline car or motorcycle, bus, and long haul flights, and medium haul flights, short haul flight, and all that. You can see that as you go to short haul flight, your carbon is much higher. Your carbon is much higher. The carbon cost is pretty high. So then transportation sector is the largest consumer of oil as well. Transport is around, they consume around 53.4%. And out of that, if you take that consumption of oil, a lot of majority of it is on the road. Or passenger vehicle, those things are there. So, and they are major contributor of global CO2 emissions, which we already talked about earlier. So you will see more details on that later on from when Ravi and Rajashri talks about this particular project in more detail and other aspects of it. So that leads to kind of recently, if you have looked into, there is also a whole concept of this sustainable development goal, which came out in 2015, this SDGs. Sustainable development goal, there are 17 goals out there. And many of these, if you look at in terms of good health and well-being, industry innovations, affordable and clean energy, climate action, indirectly even life below water, life on land, clean water, resource consumption and production. So many of these does impact what we're talking about in terms of our transport sector, carbon footprint of the transport sector, and all those kind of stuff. So it does have a impact there. So SDGs, SDGs are it's what we globally we are working on. Every country is working towards that sustainable development goal, and the focus there is by 2030 try to reach the target. Recently, because of the COVID, we are off the chart. We are not we may not be able to possibly reach there by 2030, but we will we are trying to make progress in that area. So. And then yesterday I was giving a talk related to ESG in our mining department. And if you look at ESG and SDG, they are essentially more or less part of SDG is covered in ESG. So it's many times these are all what you hear. For sometimes nowadays we are calling it decarbonization. Earlier we used to call it like environmental sustainability, try to reduce carbon footprint or total environmental footprint, or like a life cycle analysis. So many of these have very common basic fundamentals. Ultimate goal, as I said earlier, is try to make the life better on this planet and keep this planet as clean as possible for the future generation. We keep on giving different buzzwords at different times, different years, different decades, just to keep people interested. So the new buzzword is ESG or circular economy or like circularity. And then tomorrow there will be something else. Tomorrow maybe we'll come up with some other nice sounding words, so we'll just use that. So, but if you look at the ESGs or environmental, social, governance, and most of the ESG things are already covered in SDG as well. So it's at least environmental and social is covered. Governance part is indirectly covered. So those things are also there. So these are kind of just to background on why even ITF and OECD is working on this particular area. This is why there is an interest, or in fact, why there is an interest in any environmental issues today. So, and there is a lot of new You go on LinkedIn, you go on more on LinkedIn and other places, you find a lot of activities happening around the world on related to environment. Environmental area today, even the people who were not, even if you look at the researchers, many researchers are trying to directly or indirectly move towards environmental topics because it's relatively easier to get funding, relatively easier to get published, relatively easier to get postdoc position. If everybody does that LCA now. Any thesis, whether from non-environmental thesis also, you will see one objective LCA will be there because that helps them at least take paper so thoda decently published ho jayega in a decent journal. So that's okay. Like you publish papers, I'm not against. I myself has close to 150 papers now, so I'm not against publishing papers. In fact, I encourage strongly that you publish paper, but at the same time, you need to look at like at least some incremental like a benefit to the society should be there in your whatever research that you do. And that's for people offline, online, everywhere. You should also look at how it is going to benefit the society, what benefit it will bring to the society. So, and like a tangible benefit. We can relate everything to the some benefit, but it's like what is really doable on the on the grassroots level. So coming back to decarbonization. So decarbonization, it basically refers to all measures through which a business sector or an entity, which is whether a government or an organization, they are reducing its carbon footprint. And what we say primary carbon footprint, predominantly we are focusing on greenhouse gas emissions, carbon dioxide emissions, greenhouse gas, within that carbon dioxide, methane, and it's in order to reduce its impact on the climate. So that's the major focus. But if you look at in terms of what we can do, it doesn't only mean carbon dioxide when you talk about decarbonization. We can do a lot of stuff in the upstream activities. We can there is also some a lot of things could be done in the downstream. So upstream, what kind of goods and services, capital goods, fuel and energy related activities, transportation and distribution, waste generation in operations, your business travel, employees commuting, your assets. So how you are handling those stuff. See, for example, I'll give you, although today it's a bit cloudy, but on a non-cloudy day as well, we keep all these blinds are closed and we put all these lights here. Although the building should be designed in such a way so that we can make use of natural sunlight as much as possible. But we have, in the name of making things look fancy, we have now actually that thing is coming back. If you go to the Paryavaran Bhavan in Delhi, I think that's the only fully green building certified in India right now. So that has it's a showcase. That's the thing. We made one showcase and that's it. We don't try to and that particular building goes overboard. But there are initiatives already. Like if you go to newer townships in big cities, whether you are in Mumbai or Bangalore or Kochi or Hyderabad, you start seeing even in New Town area in Kolkata, they are looking at this grey water recycling, where the grey water is collected separately, where they are trying to use it for flushing and all that. And several research projects we are also working right now, where we can take the sewage and generate clean water, which could be used, even can be maybe drinkable water as well. People can drink those water too. So all those aspects are part of decarbonization. Whether you whatever activities you do in terms of reducing the overall environmental footprint, that entire thing is decarbonization. Unfortunately, sometimes what happens is because of the news media and other stuff, decarbonization does not only mean solar panel, does not only mean wind power, or does not only mean EVs. So it means you can do a lot of stuff. In fact, I would give the example that which we have been trying to work on, hopefully soon, in terms of looking at the bottom ash from the coal-based thermal power plants. If you use that bottom ash from the coal fly ash, a lot of things are already being done. But bottom ash from coal-based thermal power plants, if that is taken and used as a construction material, which people in Netherlands and other Austria and other people are already doing it. If we use it in construction material, if you don't have to get the fine aggregate and little coarse aggregate of finer core segregate as well. If we can replace this with that ash from like cogeneration plants, that means we don't have to get virgin fine aggregate. We don't have to get virgin sand or virgin those small pebbles, because we are replacing maybe 5%, maybe 10%, whatever, 15%. So that itself is decarbonization, because think about all the activities that could have happened to get the virgin material. So of course you have to do some activities in processing this as well. So that's where the LCA comes in picture. You will look at a comparative LCA to find out how much environmental saving we are doing. That will come into picture, but that also is decarbonization, because you are helping in terms of reducing the carbon emissions overall from different industrial activities that we are doing. So, and of course, towards the end, we have tried to get rid of HFCs. We have tried to like a like a carbon and the sulfur fluoride, the NF and all that. There are a lot of mercury we have replaced. We have tried to replace lead, because these are all nasty materials. And then try to have end of life processing of solid products, use of sold products, processing of sold products, end of life treatment, leased assets, and all that. So people are also looking at these days with this ESG thing which is coming up. There is a push in terms of looking at like how a company is performing in terms of its environmental, social, and governance. And there are financial institutions now, they want companies to have a certain basic ESG score. Otherwise, they will not fund them. So, which is essentially, if you do those ESG principles, you are helping in your decarbonization as well, because a lot of things will have common there. So there is a goal to go to net zero emissions by 2050. There are 8 actions are there. Increase your solar and wind capacity. Eliminate most electricity generation from coal, maintain natural gas capacity, increase zero emission vehicles here, increase sales share of building heat pumps. Heat pumps are getting quite popular. All new buildings and appliances meet the strict energy and efficiency goal. Research and development for carbon capture, carbon sequestration, carbon neutral fuels, build electricity transmission and pipeline for CO2 and as well as hydrogen gas. Hydrogen could be a next fuel, maybe. And I think especially those of you who are in the online mode, for your information, recently we received a Indo-Denmark funding with Professor Dhangrekar being the PI and myself joint PI on that, where we are looking at hydrogen generation from sewage sludge. I think Dr. Dev Chakravarti was here earlier during inauguration and he left. He was the person who helped to write that proposal. So actually it was mostly his hard work which got us that project. So that will again, of course, DST has cut down the budget a lot. So we'll have to see how to really make things happen. But that is an interesting area where if you look at the wastewater treatment plant, from the wastewater treatment plant on the liquid side, we have kind of worked on how to take the sewage and generate clean water to as much as possible. But what to do with the sludge? There are some technologies already out there, but can we use the sludge to generate hydrogen, like a hydrogen fuel? And so that's what that project will look at. So that would be interesting things to do. But for all these, whether you go for solar, whether you go for wind power, whether you try to go for all the EVs and all that, try that measuring their decarbonization potential is very, very important as well. See, when you move from, I'll give you an example in Kathmandu. I think I may have told you, some of you already. In Kathmandu, there was a lot of push because of the government policy to move from the regular vehicles to the electric vehicles for the taxis and all. So if you go to Kathmandu today, you will find a lot of electric vehicles as being used as taxis. But Kathmandu, unfortunately, gets around 8 to 10 hours of power cut. So these electric vehicles are being charged using diesel gensets. So the whole purpose is lost, isn't it? So if you're using diesel gensets, that's what I think in the last workshop, the gentleman from the Niti Aayog, he gave us this example. He was visiting Kathmandu, and when he saw that, it was kind of like what's going on? Like whole purpose of having electric vehicle is lost. Same thing, if you go to big malls in big cities, they are using so much of diesel gensets for their ACs and all that. In Saket area in Delhi, there are 2 malls back to back. And I don't know today, but around 5-6 years ago, they were running on diesel gensets most of the time because they have so much of power requirement, which local supply was not good enough. So if you have that, that is not, those kind of things does not solve the problem. So it may look something nicer. For example, electric vehicle, of course, it will help in terms of reducing the air emissions on the road. So urban areas may get better, which is a good thing. So which is really a good thing. But if we keep on using fossil fuel, what is happening? Our problem is shifting from the road to the power plant. A lot of emissions coming out from the power. It's more coal-based power generation. Unless we move to the renewables. Renewables is solar panel, wind tunnel, wind and all that. Now, solar panel after its life, if you don't manage that solar panel waste properly, then again it's a problem. Or same thing with wind turbines. What to do when it goes bad? What to do, because they are very highly metal intensive. Different metal, a lot of metals are there. So what to do? Metal mining and all that is really quite very highly energy intensive and water intensive process. So you have to look those things. So you have to look at that those aspects as well. So when you look at all these different 8 actions which is being looked into, we have to kind of have that holistic approach and go for more on kind of decarbonization. So those of in the audience, if you're on the online, if you have any question, please put it in the chat, and we will be taking up the question towards the end of the talk. And like if towards the end, if we time permits, we'll also have you unmute and ask questions. If that works, if you like that way as well, we can do that. But for now, if you can keep yourself mute, it's better for the all other participants who are out there. So in terms of decarbonization, as I said, we have to measure it. Like what is the benefit of any activity that we do for decarbonization? So there are different measurement techniques are out there. There is a carbon emission calculator. There is decarbonization action plan tool. Renewable energy optimization is there. Life cycle greenhouse gases. There's a Lighten UP, which is another tool. There's a tech test tool. So there's a variety of tools. There are so many consulting companies that are out there. They always come up with a newer tool or the other. Similarly, we were looking at, as I told you that yesterday I was giving a talk on ESG, and I found that so many companies are already out there which is giving ESG ratings. Now, but there has to be some sort of a standardization. Once any new things start, you will see a lot of consultings and things will come up with different methodology, but at some point of time there will be a standardization. Like for example, for LCA we have a ISO standard. We have to follow ISO standard to call it a LCA study. So you can do some carbon footprint calculation study, but to really call it a life cycle assessment study in a peer-reviewed publication wherever, it's required to follow ISO methodology, and we'll talk about that methodology in a while. So current energy mix in India, nearly 54% is coal. That's 2022 data. And then we have hydro, nuclear, natural gas, and all that. So renewable energy capacity has increased in India quite substantially. Solar tariff has also gone down. And then this much lines have been constructed for green energy and all that. So this is cost is there. Now, if you look at the renewable energy total carbon dioxide reduction potential as compared to the coal, for renewables, you get 25 to 45% reduction based on your plant utilization factor. Gas is around 50%. These are all compared to coal for the same level of energy. Renewable plus gas is 35 to 55. Renewable gas is storage is 45 to 65. Cleaner coal technology to reduce, we don't know right now. So moving away from coal is definitely helps, but we have to look at how much it is helping. So that's kind of important part. So when you look at the other aspect like oil demands and carbon dioxide emissions for the India's passenger and freight transport. This is the media out of in 2020. So if you look at 2020 to 2030, if in terms of the CO2 emissions, if we can go for passenger vehicle and the freight vehicle, we will see some reduction because based on how we are working today. But if we go for more like a efficient scenario, from business as usual scenario, we are from 2030, there's the passenger vehicle and the freight vehicle. We are going to see some drop, and this is for cumulative oil demand. We'll see some drop in the cumulative oil demand as well. This is based on the efficiency that is coming into the sector. So that's as I was trying to tell you several times in the last 15-20 minutes or whatever we have been talking so far, around half an hour actually. So we are there is a we kept on saying that you have to find out what is the true decarbonization potential. What is the its environmental footprint, like how to do the environmental footprint calculations. Or so this is LCA, which is has been around for quite some time now, and it has a ISO standard. It's essentially life cycle assessment. So in a simple way, if I want to say it, is that we are for any process, any product, or we just want to find out what is its overall environmental footprint from the very beginning. Very beginning means from the getting the raw material acquisition all the way to its disposal and possible recycling and bringing it back into the economy with a circular economy approach. In fact, people these days talk about cradle to cradle. Earlier, we used to say cradle to grave. In hazardous waste management, also that manifest and all that, we used to say cradle to grave. Now people say cradle to cradle. And I make a joke that the entire world now is trying to believe in Punarjan, right? Like a cradle to cradle, but it's a Punarjan, like you are rebirth. So cradle to cradle means no waste. Try to move towards zero waste. Zero waste literally doesn't mean zero. Zero means try to go as low as possible. As some of the European countries have achieved less than 10%. So they have less than 10% waste there. So that's your. So in terms of your like a LCA, as I said, there is an ISO standard. So as per international standard ISO, which is a framework for LCA, that they say that LCA is the environmental impact aspects and potential impact through a product's life, which is cradle to grave. This is what cradle to grave, but nowadays we're talking about cradle to cradle as well. From raw material acquisition through production phase, use phase, and its disposal phase. The general categories of environmental impact include the resource use, human health impact, ecological consequences, aspects, and impacts of product system. So in the diagram, if you can look at, it starts from your getting the raw material, the resources are processed and taken to the manufacturing plant, then distribution, then it is used in our houses, the end of life, and the cycle continues. End of life, it is getting recycled, resource recovery, it will come back into the economy. That's the circular economy. Otherwise, at the end of life, it goes off from the economic activity and it becomes part of the waste sources and goes into the landfill and other places. So LCA is very similar to environmental accounting. So very similar to your any business accounting that you do. So if you look at any business entity that you have, at the end of the year, you do the financial balance sheet, that all the money that come in and all the money that got out, and then you try to do this stuff. Here we are doing an environmental accounting. So here, rather than doing financial accounting, we are doing environmental accounting. In terms of what is the environmental footprint of all the materials, energy that is being used coming into the system, how much, what is the environmental emissions and other things going out of the system, and what is it? So then we try to add them up together. But since I will show you some examples. Even for some very simple products, it becomes so complex to get things done that we have to use what is known as database, or we have to use some sort of software. Because even say if you want to your mobile phone. Many of us have a smartphone today. I'm interested to find out what is the environmental footprint of this mobile phone. So what do I have to do? I have to first take it apart, take an old one of these which doesn't work, take it apart, look at all the different components which is there, and then try to identify what is the energy was used, how much water is used, what kind of chemicals are used in terms of manufacturing them. So as simple as this may have 100 different components here. So different types of plastics, different types of glass could be there, metal is there, printed wire-board could be there, a lot of different things which is present, and they do have your they do have, each one of them has certain, and you cannot collect data for each one of them individually. So you have to rely on some data which has already been collected from somewhere. So you use that data. So that is that's why the database is important. We'll talk about that. So similarly, you have to get all the data in terms of emissions also coming out. Say into raw material data as well as the emissions data. Now, once you get the data, what to do with the data? So you need to have some sort of interpretation method. So let's start looking at one by one. So if you look at like LCA, it's a limitation is that it is only focused on environment. So LCA, as we know, it is only focused on environment. It's not, when we talk about sustainability, sustainability has 3 pillars: environment, economics, and social. Our like LCA is only focused on the environmental. There is a LCCA, life cycle costing assessment. Life cycle costing, cost benefit analysis, and those kind of stuff that you can do for your economic aspect, economic stuff. Then you have a social LCA is also out there, which you can do from a social aspect. Social LCA methodology is kind of a bit not that clear. It's a bit abstract. It's a bit subjective because certain things social, even within India, if you look at what is socially acceptable in one region may not be socially acceptable in the other region. So, and then when you talk about the entire globe, of course, there will be a lot of confusion in the social aspect. Social aspect, that's why it's in the ESG, they have tried to capture the social aspect more in terms of, because they are trying to look at the social aspect more from a business perspective. Like whether, if you look at the ESG part, which is kind of, again, old wine, like a different states of wine, I would say. Not same wine, but different states. Maybe one is Australian, one is New Zealand, one is from Italy. There have been different places where wines are produced. Like in Australia, actually, they have a lot of wineries. Go and see how the wine is. So, and then wine waste is a big problem there. That's what Abhishek just walked out. Abhishek is trying to have his like postdoc project there on winery waste. That's what he's trying to focus on. So it's in ESG in terms of social aspect there, which is there in social LCA as well. From the what is the UN guideline out of a social LCA, like how much is the fairness in employment, like what is the where you are getting proper pay for the job that whether are you underpaid or gender equity all the way up to the board of directors. Whether the board of directors you have diversity in terms of gender, in terms of different types of people, so ethnics and all those different diversity should be there. And what you are doing for your employees' children, what you are doing for your surroundings. So those things are quite important there too. So, but the limitation for when we say about LCA, it is only focused on the environmental aspect. If you are looking at economics, you have to go and do LCCA, life cycle costing. And then if you have to do for social, there is a different tools out there. If you have to do some social, especially becomes a lot of survey. The problem with the survey is that most of the people don't say negative during survey. Especially if you are doing one-to-one survey, then it's become more, well, maybe people will feel bad about it. So, theek hai, pareshani to hai, but fir bhi chalo theek hai. So it's so that is very difficult that in the surveys, designing the question, asking same thing in a different way just to find out those biasness or those error is very, very important. That's where the statistics and all those comes in picture, where you try to answer same thing, but different types of question, and to make out that whether they are really answering you correctly or there is some biasness going on in their head. So that becomes quite tricky to do. So there are the exclusion of economical and social factor is there, LCA in product line analysis. So that separation was made to avoid a method overload. Being well aware that it is on that decision. So in the development of sustainable products, we look at all the three: social, environment, and economics, and that's where your ESG comes in picture, where they are trying to look all three together with one score. So at the bottom, you can see that LCA framework, which is essentially from ISO document, that yellow box that you are looking at, where we have the goal and scope definition, inventory analysis, impact assessment method, and we'll talk about those in more detail. And then you have your interpretation. And you can take that, and what you can do, like the question is what you will do with this. In the context of this project that we are talking about, our focus is decarbonization. So if we know what is the environmental footprint, we can work on, say, if you're moving from your regular petrol-driven car to the electric vehicle, you should be able to find out how much benefit it is going to make. How much benefit it is going to make based on today's energy mix. As we make more progress in terms of renewable energy and all that, whether how much more benefit it will make. So those things, those calculations can be done using those. You can use for strategic planning, public policy, marketing, and others, and all that. So life cycle assessment, it's developed over the years. CTAC, which is the Society of Environmental Toxicology and Chemistry. So CTAC got involved, and they looked at life cycle assessment in terms of this in 1990s. If you look at the history of LCA, in fact, although they did not call it LCA, but the first LCA type exercise was done by Coca-Cola in 1969, which was not a complete LCA, where they were trying to look at whether to move from glass bottle to plastic bottle. In today's context, that sounds really weird, isn't it? But from glass to plastic, why the hell they would like to move for it? But if you look at the breakages that was happening in the glass bottle, so to clean all the glass bottle, you are supplying the glass bottles, say, all over the United States, and then the cleaning plant at that particular time, based on where they had the cleaning plants and all that, collecting all, bringing it back. Glass is heavy, transportation is more, transportation cost is more, the fuel consumption is more. So based on all that, they kind of come up with actually moving from glass to plastic was a better thing to do. They did not include the improper plastic waste management stuff there. See, plastic has problem, but the big chunk of plastic problem is because that we are not managing the plastic waste problem. Especially when you're talking about plastic bottles and all that. When you're talking about those thin bags and when you're talking about those micro beads and all those stuff, then it's a nuisance. It's a nuisance that we have in terms of these plastics. But in terms of your like a good plastic products, like what your computers or your like if you go to any hospitals, you walk into any chemistry lab, whether you're TOC, whether you're GC or other stuff, a lot of plastics are there. So they are not, in fact, that has helped us to make the product lighter. In fact, if you think about plastic, there are a lot of good things that plastic has also done. Today's Maruti car has more fuel efficient. One of the reasons it is light. Vande Bharat can go such faster because it's mostly plastic. Yes, we should not, God forbid, we should not have any like a crash of Vande Bharat with some other accident. That will be that will have a lot of more problematic. Vande Bharat has been made plastics and aluminum. So it's like our Maruti, all the cars that we have, a lot of plastic. So that's why it makes it lighter. Lighter, it can travel faster. More fuel, less fuel consumption, better mileage. Of course, engine is helping there too, and engine is doing a big bulk of the job. but having a lighter vehicle also makes it quite useful in terms of fuel consumption. So that when we talk about negative impact of plastic, we forget about the positive impact of plastic. All the different shapes and sizes that we have, like giving this shape of a mouse from metal or from glass, or that's not the material we have today. I don't know whether we'll be able to do that. So plastic has helped the keyboard, a lot of stuff, which does help a lot. But we have been misusing plastic a lot. We are becoming lazy, using those plastic thin bags, and a lot of use and throw material. People throwing away parties where you use all those plastic cutleries and other stuff, and at the end of the day, you're throwing up on the side of the road and getting into the stream, then finally goes to the river and finally to the ocean. So that's where the problem is actually. So of course, we need to cut down single-use plastic usage, which is actually more than 40% is single-use plastic. Rest 60%, which is your laptops and other stuff, your lab stuff, medical industry, construction industry, all these chairs and tables, a lot of plastic components there too. So that we cannot live without all this. Like say today, if somebody says that we'll not make any plastic anymore, so many things we cannot do. Probably will not be able to brush. so that's what. Or toothpaste. See, toothpaste is inside a nice plastic pouch. Earlier we used that Colgate powder was there. So paste was not there before this plastic came into it. So they have done a lot of good things too. But we are actually misusing plastic as a material. That's where the problem is. So when you try to do goal, then the CTEC, like a life cycle assessment, there's a goal definition and a scope, impact assessment method. We'll talk about that in more detail. Then ISO came up. So these are the CTEC stuff in the beginning in terms of methodology. Then they have another triangle with goal, scope, and all. Then these things have been taken up. And then ISO came up with slightly more simplified diagram, which is essentially talking the same thing. We're having a goal and scope definition, inventory analysis, and impact assessment. So when we say goal and scope, is why you are doing this. What is the goal? What is the goal that you are trying to solve? What is why you are why you are planning to do this LCA? How it is going to serve the purpose? What purpose it is going to serve? Because that's very, very important. What will be the scope? Because anything you can make it, say, for example, even when we talk about decarbonization, or say, take the example of which is very popular these days, electric vehicle. Again, let's talk about electric vehicle. Now, electric vehicle from the gasoline to electric vehicle. If you do a comparative LCA, what is the scope that you are looking at? Of course, you start from the manufacturing of both the vehicles, of the different components, the batteries, when the EVs, charging of the batteries, end of life of that batteries, whether it's the component of the batteries are being recycled, brought it back into the economy. Are we doing the entire cradle to cradle? So that is the scope you are looking at. And say that also depends on what is the goal. If your goal is to know in totality that if I move from my petrol car or diesel car, say for the city of Kharagpur, every car will be, or IIT Kharagpur campus, every car will be electric one. So for all purposes, we will use only electric vehicles. If that's the goal, to find out if we do that, what positive impact we are going to bring, how much carbon footprint reduction we are going to have. If that's the goal, then of course we should look at its entire stuff. But then if your goal is to kind of look at only in terms of improving a certain component of that particular car, you did a rough LCA hotspot analysis, and then you know that yes, this is among the battery manufacturing, this component, this unit is what is creating a lot of nuisance. Let's work on this. Let's look at the alternative to that. So then you will just do a comparison of that particular component with potential alternative to it. Like for ABB, like recently we have, those of you who are on, we have a project with ABB right now, where ABB has a electrical kind of switch, where we had dismantling of look at the different components, and there the goal, what they want is to find out what is its existing product, what are the issues with end of life, Their focus is that their goal is end of life. So our LCA is focused more on that aspect. Different end of life options. What is the thought picture? If they wanted to us to look at even the production and all those phases, then we have to look at the entire life. So it all depends on what is the goal. What is the goal of that? What you want to get out of? Because whatever LCA exercise you are doing, you're not doing it for fun. You are doing because you want to have some output from there, which you want to make use of in your decision. Isn't it? So that goal has to be very clear. Similarly, some of you working on your PhDs and master's thesis and all that, you want to have an LCA as one of your objectives. So what is the goal there? What you want to do as part of that LCA? How, like, what question you want to answer as part of that LCA? That's very, very important. And that defines what the scope will be. Now, once the goal and its scope is finalized, you start focusing on inventory analysis. Inventory analysis is collection of all the data. And that's the more critical part of LCA. Having good quality data. Most of the industries, like we have worked with some industries, Ravi has been involved with many of those projects, like when we went to the dairy industry and the other industries, they do not really collect data because they have never thought that they will do LCA. So the plant is not set up in a way that you will have those kind of data. Say if you want to do the hotspot analysis and to try to find out which unit is having a higher energy footprint, energy data is only for the entire plant. The meter is only at the entire plant. So what you have to then start breaking down, okay, how much pumps or compressors or what is the wattage, individual units, and then you try to allocate based on the total energy usage, what is going into individual units. And at that time, you may have to do some guesstimates, some estimates, and then you will put some numbers there. So getting if the energy data is correct, you will be able to find out. Many times the data quality is a big question mark as well. They don't really, because they have never cared to do it. They haven't thought. So the plant is not designed in a way so that you will get the data which you will be able to do LCA. So that's why the data becomes a big problem. And for some of the very simple stuff, like if you want to concrete, steel, and other stuff, we rely on our like data which is there in the database. A lot of data is available in the database, but then in the database also, you may not find the data in the way you want it to be. So you have to really wrestle around and try to find the best possible scenarios. That's where the lot of problem in LCA. Professor Ghangarekar was mentioning in the inaugural program that India-based data is not available, and which is a big problem. In fact, EcoInvent is trying to have India-based data. At least energy data is there, and so I think cotton data is now there as well. So a lot of data is present now in terms of in India, specific data is available, but it's a long way to go if you compare the data which is available from the European Union side. So that's the inventory is collection of all the data. Then you have to impact assessment. You look at, so based on all this that impact that you have, like what is impact in terms of the different impact categories, and those impact categories are essentially coming from the IPCC document, Intergovernmental Panel for Climate Change. That document has different impact categories. So you try to take all these emissions data and everything and try to relate it to different impact categories. There also a lot of subjectivity comes. There also you will have a lot of issues associated with how to allocate one particular emissions may be related to a variety of impact. So which impact should be, like, if it's 3, should it be 1/3, 1/3, 1/3? Should be 50, or it is 50, 25, 25? Or which impact category you will choose out of all those impact categories which is out there? Which you will use. So there is a lot of, so there are different impact assessment methods out there, which has a certain protocol, but you need to understand what the impact assessment method is doing. In the software, you will be able to choose an impact assessment method. Everybody is doing recipe, let's choose a recipe. But what is happening in that recipe method? What is actually they are doing as part of the recipe method? So that also understanding needs to be there. At least, especially if you're doing it as a part of research or part of any particular project. So those are your impact assessment. Once you have that impact, then you will try to interpret what to do with that information. if you start looking at all those impact categories, all those nice looking graphs, those bar graphs that we get from SEMAFRO or other softwares, but then when you get all those graphs and then you start getting confused. They look very beautiful, but what does that mean? What these graphs really mean? So we have to interpret that. Why your graph shows those kind of data, or those kind of graph you got. What is so that's kind of important, like why it is, and if you are looking at certain impact categories showing more, less, why? So those explanation has to be there in terms of your interpretation, especially if you're looking at an LCA practitioner. That's from the research point of view and practitioner point of view. But if I'm an LCA user, what I want is a simplified version. If I'm running a business, I don't understand all those impact categories. I have no idea, because if I understood all that, why should I hire you? Yeah, that's what the job of the consultant. So kind of understand this and tell them in a nutshell, what does that mean? So people have come up with a single score these days. Like you can try to, again, looking at all those different impact categories, having different weightage to different impact categories, you come up with a single score. It's a very similar to Bombay Stock Exchange that index, or air quality index, water quality index. So it's a single score. Say if you're doing that presentation in front of some bureaucrats or for politicians, and you start showing them all those that CO2 equivalent from this eutrophication and acidification or marine ecotoxicity, they will say, no, I don't understand any of this stuff. So please tell me whether it is, if I set up this plant, whether it will be good for the environment nearby, or whether it will help me reach my COP26 promise that our Honorable Prime Minister has made. And if it help us to reach there, will it help us? What percentage it will help us reach compared to the existing plant that is working with whatever the existing technology, how much benefit it is going to bring? That's what, for the environmental, those questions will be. So we should, simplification many times is not a very good thing to do, especially when we look from a research angle for those. But if you look at from a practical applications on the field, simpler it is, better it will be implemented. So we need to have a balance. We need to have a balance where you simplify it with the strong science fundamentals. You don't simplify it with some trivial assumptions. You have to simplify it with as much as a strong fundamentals you can keep it. So of course there will be some trade-off. So that's what we need to kind of work on. So again, life cycle, ISO methodology, we talked about all that, interpretation, direct application in terms of your product development, strategic planning, and public policy making, marketing, and other stuff. All those things are there. So goal, why is it needed? It's already 12. Okay, I thought I have too much time. Now I have to speed up. So because I'm only at, I have only 1/3 done. In terms of the, but later on I have some examples which we can go faster. So the goal is, why is it needed? So like why we are doing LCA, which we talked about that. What is the purpose of doing this LCA? If the study is to, so it's whether you want to, especially if you are trying to improve the environmental performance, then only you need an LCA. If a study is to provide economic advantage in the marketplace, you might view it differently as to one intended to optimize a process. And of course, you have to look at the economic aspect there too. Who is the audience? If the audience is saying, doing it for a research purpose, I'll go in more detail into those processes. Even research on how to do LCA. Is the methodology that we are using today is good enough? In fact, that's why I want somebody to do PhD on. But somebody who is really good into number crunching, mathematics, and writing the big equations and all that. It will be good. We don't have to worry about this gem and all that. We can, with a laptop and other stuff, you can focus, but you need a lot of self-motivation, because lab-based work, what happens is you do some experiment, you say, get the data, at least push to hell, like, so at least you have something to show. But when you start working on these kind of stuff, unless you are self-motivated and keep making progress, at the end of the day, you may not have anything to show, especially when you are doing those modeling stuff. So, but that's a very, very important things today. Like how to argue that all these LCA methodologies that being done, is it the correct way of doing it? Or should we change the process? Is it really capturing everything? Or is it making it, sometimes it feels many of the SMEs, like small and medium enterprises or MSMEs, they find it very complex. They find this LCA exercise to be very complex. Like the one they started when GST was started, it was too complex. Then it was simplified, but this is much more complex. Getting all the data, so they feel like at least they have to hire one employee just to kind of do this, having a hang on data and all that. So, and they approach consultants, and we consultants make them feel that yes, it is very complex. We will not be able to do that, so that they keep on coming to us. So, but is there a way? Can we say, for example, those of you who are in the audience in online as well, if some of you is interested, can we create a web platform where we make it as very simplified? Again, not losing the basic fundamentals. That's where the challenge comes. See, you can create any. There are already some LCA websites are there. You can calculate. In fact, you can calculate some of your footprint and other stuff. But how is it really the true capturing everything? So how to have a scientific but simple. That's where PhDs are required, isn't it? So where we need to kind of make that happen. So that will be quite interesting. So if any one of you is interested, we can talk about that. Then and then when we do LCA, what is the goal? What is in terms of goal? Are you comparing how critical the different processes are? In terms of if you're doing comparison, then ISO does not permit weighting of compacts. ISO demands peer review of the study. And there are peer reviews should happen. Identify stakeholders who should be involved in those peer review. So in the defining of the goal, which we kind of mentioned earlier, we have to be pretty clear in terms of why the LCA is being done. What is the thought process behind this study? What is its intended application? How this study will be used? Intended audience, to whom the results of the will be shared, who the study is going to be aimed at, and whether you're doing a comparative assertions and to be disclosed to the public, whether you're looking at a standalone LCA, all those things you have to kind of look at. Then you move towards the scope. The scope is try to have what is the breadth, depth, and the detail of this study. And LCA is an iterative technique. You do an LCA, and then you may find that the scope that you started with actually is not good enough. You have to modify the scope because the data is not available. You may not be able to do it that particular way. So you kind of redo the LCA. One good thing about most of the software is once you set up everything on the software, do the iterations and other stuff, it's relatively quicker. Doesn't take that much of a time. In few weeks of time, you can kind of redo your LCA as long as you have the data. So what is you modifying if you as you collect additional information, and there are certain aspects which is I'll give you an example which will make it much clearer in terms of function and functional unit. But for any of these LCA, these terms are quite important. What is the function? Like if I want to compare like even different ways of travel, since you're talking about transport. Like decarbonization of transport infrastructure. So even if you look at, for example, transport fuel, petrol, diesel, bio-based fuels, electric vehicle. So if you want to compare all these four, now the function here is what? Function here is to move goods from point A to point B. So that's the major function. So we can say maybe 100 kilometer worth of travel. 1,000 kilometer worth of travel, which is same for all four. So that becomes your functional unit. That becomes your functional unit in terms of how much. So we will do all these exercise. We will do all these exercise in terms of in your all these exercise will be done with that 1,000 kilometer in mind, like taking things from point A to point B using 1,000 kilometer, whether it's a petrol-based, diesel-based, bio-based fuel, blending with petrol, diesel, or it's an electric-based fuel, whatever you are doing it. So in terms of that's the function of the product system. Say when you talk about comparative LCA, whatever the new product is there, it should be able to do that function. It should be able to do that function. Isn't it? Say if you're packaging food, packaging milk. So if you come up with a new way of packaging milk, that should be able to do the packaging as it is being done with the existing one. It should not, the product quality should not be inferior. So you cannot make an inferior product and claim it to be environmentally better. So that's what it should do, similar stuff. Then you start looking at product system, where you can start looking at your product system in terms of what like product system to be studied. You come up with the system boundaries, whether it's a cradle to grave, cradle to gate, gate to gate, cradle to cradle. All those different system boundaries are there, and I'll show you one example. Look at allocation. Sometimes you have a variety of things going on. So how you will allocate in the impact methodology, data requirement, assumption limitation, initial data quality requirement, format, how will you report the LCA that you will do, all those things kind of comes in picture. Functional unit, I already kind of explained it. We will be sharing this set of slides with you. So that's why we have detailed, kind of gone into detail in these bullets. I'm not going to read all that. We have kind of already talked about that. Functional unit is essentially to find out for what, say, whatever function, we have to give a number. Like I said, 1,000 kilometer worth of travel for different modes. So all the calculation that we will do for that comparative LCA will be based out of 1,000 kilometers. 1,000 kilometers of stuff. So that becomes your reference flow. All your data that is collected is based off 1,000 kilometers. So that is also known as the reference flow, as in one of the bullets here. Having chosen the functional unit, the reference flow shall be defined, and then comparison becomes an easy. And if you have additional functions are not taken into account, for example, like kind of talk about sometimes if you talk about the e-book versus regular book. E-book versus regular book. Regular book, you are reading a book. You are also putting the book behind in the shelf. Looks so nice. You walk into somebody's office, has a lot of books in a bookshelf. That gives an ambience there as well. That gives a feeling that this particular professor or this particular gentleman possibly reads a lot, although maybe they have never touched that book for many years, but they look, whenever our Honorable President of India gives a speech, on the back you will see a very nice hardbound books. So that gives a very good ambience. But I'm not saying that she does not read it, she must be reading it, but I'm just saying that it creates an ambience there too. But you cannot quantify those ambience. You cannot quantify the feeling of the people walking into the room when they see those books. You cannot put, so those things cannot, but the book can be used as a paperweight too. But can we have how to see, you can replace your regular paperweight in your office by using a book. That may work. But we don't take those things into consideration because those things are very difficult to take into consideration. Similarly, ebook, one ebook can have thousands of books there, depending on how much of a storage. And reading physical book has a different feeling. Reading ebook, for someone like me who is getting older, ebook never. I'm reading something on the laptop or ebook is. I don't enjoy that much as opposed to having something physical. So a lot of things are there. It becomes very complex. So it just as simple as comparing certain things, it gets quite complex. So that's where we kind of go with some rules and regulation. Some like information here, some slides in terms of a lot of work has been done since our group works a lot in the waste management area. There are a number of studies have been done in waste management in high income, upper income, and low medium income and low income countries in terms of a lot of papers already out there. So this is also quite popular in waste management, quite popular in terms of looking at different types of waste, like different types of your functional unit and all that, dairy waste for energy, annual waste, 1 ton of waste and all that. So if you're looking at a waste, just for an example, if you're looking at something on waste management, so there you have to look at, again, what you are, just 1 second. So right, if you look at that, it's your, you have to look at the system boundary. So it's starting, you see the dotted line, that dotted line is your system boundary, where you start from generation to storage, to collection, to transfer and transport, processing and treatment, and then finally disposal. So in terms of processing and treatment, you can go for composting, material recycling facility, incineration. So if you do the entire thing from the beginning, as you can see at the bottom, from the entire thing, that becomes your cradle to grave. That's your system, that's your scope, cradle to grave, and then your system boundary is cradle to grave. Other thing you can do cradle to gate. You start from generation and you just look at the transfer and transport, and then there could be different ways of treating it. So you just say we are cradle, just the collection system. Just for you, if you're just focused up to the collection system, you can do that as well. Not that much relevant for waste management area, but if you're talking about a product development, quite relevant. So if I'm making a product, many times companies tell me that once I've made the product and the product is gone out of my area of my company, it's very difficult for me to track what is happening to the product. So how should I be responsible for it? In EPR, we said that no, you are responsible as part of the extended producer responsibility. But in general, and they also have a fair argument if you look at it, because it becomes so complex after this in terms of somebody using it, people may be using it in a different way. So that's your cradle to gate. As soon as leaves the gate, that especially for products and all, that's more relevant there. But sometimes it could be gate to gate as well. So if you're trying to look at one of these waste treatment technologies, or even you are looking at any technology, you're trying to compare option A versus option B versus option C. So there, say for example, composting, I can go for windrow, I can go for activated like drum compost, or I can have different technologies out there for composting. If I want to compare these different technologies, in that case, I can do only gate to gate. Waste coming up to the gate of the compost plant will have the same environmental footprint, whether it is using technology A versus technology B versus technology C, unless we have that, no, the waste has to be collected in a particular way for a particular technology. Then it's not that, isn't it? Otherwise, it is it's the same. So you can eliminate that part. You can just focus on gate to gate, just looking at within the compost plant, what is happening. So those are different ways of doing your LCA exercise. And the same thing, same example can be done. So if you look at the entire stuff from the very beginning, started from your collection system, generation, storage, collection, transfer and transport, processing, disposal. You take the entire, you can do for each one of those system, you can do an individual LCA as well for each of these units, but overall you can do for cradle to gate. And then you have data for each one of these aspects, collects a lot of data, and then you use the data in terms of like a interpretation and all those kind of stuff. And then you try to make use of your interpret the data, get the information, and then improve upon the system. So that's what can be done. And these we have talked in quite detail in our, we do have, at the end of this slide, I'll show you that we have an online course, which is going to run next month, starting next month, and which we cover in great detail about this in that course as well. So data quality requirement, the data should address in terms of it should be good data, good quality data. So that's very, very important. Data collection is one of the major component of any LCA exercise. If you can do a good data collection, that solves your 60 to 70% of the problem. So time-related coverage, geographical coverage, technological coverage, precision, completeness of data, consistency of data, source of data, uncertainty of the information, all those things has to be taken into consideration. Then we have this life cycle, like once you have the data that you collect in terms of your data to the different unit processes. You aggregate the data, so it's kind of, and then you validate the data. You whatever the data you have collected, you try to validate as well to find out whether its data quality is good or not. So simplified procedure for inventory analysis. Here that you start from goal and scope. You look at prepare for the data collection. You collect the data, validate, relate data to unit process, relate data to functional unit, aggregate the data. Then, if required, refine the system boundary. Then you go back again if needed, and then you may have to do some iterations there. So that's your stuff. And then your in terms of if you get all the data, once the data is there, then you start with different LCI component. If you look at a product system, you include all the unit processes, elementary flows, and product flow across the system boundary. And essentially, property of this product system is you look at its function and what function it is going to do, and then you try to look at try to compare based on the function and the functional unit. LCI components. So this is what happens in the software. So you have different unit processes. So even if you think about wastewater treatment plant, is starting from primary treatment also several units, secondary treatment several units, tertiary treatment several units. So a lot of unit processes are happening. Within the units, there could be another sub-unit processes are happening. So for every unit process, there is an elementary flow in and there is an elementary flow out. And this is what happens in the background in the software. You give the data and then you come up with your process flow diagram, and then the software allocates all that based on the information that you have provided. So unit processes are linked to one another, to the flow of your intermediate products. So say in terms of some example, like you can have crude oil in ground or solar radiation. Those are kind of going into your unit process. Coming out of the unit process could be emissions to air, emissions to water, or some radiations coming out. And then some intermediate basic flows, the basic materials and sub-assemblies that you do. Like within, they may not have any product coming out, but it's one raw material process, then goes into this second process, like a sub process. Then it goes to another process. So what we do is basically it becomes like a box. So there are several boxes within a box in terms of different unit processes that is happening. Good thing about that is most of these are already been for most of the standard procedures like concrete production, steel production, even making 1 ton of plastics, PET, SDP, these things are already quantified as part of the life cycle inventory. And the data is available in those databases, which we kind of tap into. So how does the system, like you look at the impact assessment? Impact assessment is you try to find out, okay, what is how the system is affecting the environment. You look at environmental interventions in terms of classification, inventory assigned on qualitative basis to previous pre-selected impact categories. So what are the, you have the impact categories specifically coming from IPCC documents. IPCC has several impact categories, so we choose. That also depends on what is more important for your area. So whether it's the global warming that you want to focus on, or whether it's the water, like water usage or your land impact. So it depends. You choose different impact categories out of the variety of impact categories which is out there. And then you relate all your emissions to that impact categories. So different substances contribute to environmental impact or quantified. You aggregate them into their specific effect. And then the aim, then you normalize. You normalize to have a better understanding, relative importance. And then you try to do some weighting. Weighting depends on, especially like which one you think is more important. And relative weighting, you try to do that there as well. So that, then after this, these are some of the, like for example, climate change, the impact categories, like alteration of global temperature caused by greenhouse gas. You look at the disturbance in global temperature, and then you are considerations in the greenhouse gas and the global warming potential, for example, methane, sulfur, hexafluoride, and all that. Damage categories is what is the negative impact because of climate change, impact on crops, impacts on forest, coral reefs, temperature disturbance, climatic phenomena. And then we try to put them into kg CO2 equivalent. In fact, all impact categories, finally, we try to convert everything to kg CO2 component, which is kind of similar to, see, when you do hardness, you go kg, oops. When you go hardness, you go to in terms of kg CO2, like this much of CaCO3, isn't it? So similarly here we put everything in the, because for CO2 we have taken the baseline as 1. So everything is related to that kg CO2 equivalent. Okay, but this gentleman is trying to enter, but then looks like it's not working for him again and again. Then you also look at whether you are looking at regional, global, or local. Global is your climate change, stratification or ozone depletion, acidification, eutrophication. Those are your global. Then your regional is acidification, eutrophication, photooxidant, water resource depletion, which is more of a regional impact. Local could be the toxicity, human toxicity, biodiversity loss happening in local areas, soil erosion, landscape degradation. So those are your these are the different impact categories. And then we look at the baseline. Baseline is what is the basic, what is the present status in terms of all these different categories, and then what is the study specific as well. If you're looking at some study specific impact categories, also we look at them. So this is how it is calculated. In fact, if you're looking at, for example, climate change, infrared radiative forcing based on IPCC model, you come up with global warming potential. You put at how much, you look at the half-life, CO2 and methane, and then 20 years, 100 years, 50 years. And then this is your IPCC document. So this system is releasing 50 kg of CO2, 1 kg of methane. So in terms of greenhouse potential, 50 kg will remain 50 only. Methane is 25 times more potent than CO2. So that will get multiplied by 25. So in total, it becomes 75. Isn't it? 50 plus 25, 75. Because so that's your 75 kg CO2 equivalent. That's the global warming potential for that. So that's your, and then you, this is the, there are different softwares also out there. Like a number of, there are different softwares out there in terms of, especially related to municipal solid waste. Variety of softwares are out there. A variety of studies which are out there, they have used, but we see that CIMAPRO, which we use in our camp here in our research group, that being older, being a little bit easier to use, is kind of more popular. The Gabby and EastTech is used as well. EastTech is kind of specific to waste management. There are, in fact, I was talking to somebody, there is some specific LCA now only for remediation. So for, I think there is a particular term for that. They just focus on remediation projects. So there are different domain specific LCA tools are also coming up just to make things simpler. So that's what I was talking to you earlier, that can we come up with some web-based platform where people can register, and of course they will have to pay because somebody is running that web-based platform, so they also have to make some money. But if it's a web-based platform, once they define their problem, they get a data sheet that these are the data that you need to collect, and then they should give the source of the data as well, so that there should be a data quality check of that. I don't know how to make all these things happen, but then you put that in in your software. You can make some interface and then generates the report, then interpret the report, and they can choose. So make it something like, not, some of you may have used Langium model. Langium model, which is the landfill gas emissions model, which is a Excel spreadsheet based model. And they have, since it's a simplified, it's only 2 equations there. So it's much easier. We are just looking at how much methane will be produced from a waste in a landfill. But here the factors are too much. But how to take at least few of those impact categories and start with, and then to do those calculations. That could be a good product. And if that could be a nice PhD exercise as well. Okay, so then these are different impact methods. As you can see, there are a variety of impact methods out there. Each one of them has their own rationale of those different impact methods, which is being used. And which again, in that online course, we talk about that in slightly more detail. Then this is again talking about number of studies. We are looking at different impact assessment category that they have looked at. That it was a full coverage for different impact categories. That's fine. Non-toxic, toxic. Then you have your input and output modeling parameter used in selected studies. In some studies, they have not been, blue ones are included. orange one is not included. As you can see, many of those doesn't include, for example, capital goods, chemical characteristics, uncertainty analysis, which is nowadays, earlier you can do your LCA without uncertainty analysis, but today, if you want to publish your LCA in a good journal without uncertainty analysis, it's very difficult. Then again, there's a number of studies related to LCA for waste management. You see more on collection transport. Collection transport is included, and then some has landfilling, leachate treatment. You see mostly not there, but other call bars are blue, which is most of them do include all those different categories. Okay, so then you have normalization. Aim of normalization to better understand relative importance of these results. And then you put some weighting as well. You put some weighting to normalized category, assigned a numerical factor so that you can get a impact score. So life cycle assessment, your goal is scope, identification, your completeness, sensitivity check, consistency check. So those things you do are in terms of impact assessment, inventory analysis. And then finally, you come up with your direct application in terms of these factors. This is again coming from ISO document. So that's kind of gives you an overview of what is LCA is done. I'll just run through some examples very quickly. Like very simple example, just to reiterate what we just said, so that you can, it will be more of a recap. And but why we do LCA? This cartoon kind of is a good example of why LCA kind of exercise is needed. Any of you who have listened to me before, in most of the time I put this cartoon up, especially I'm talking about LCA part. Here in the top, this gentleman feeling very dirty. Diesel is there, with exhaust coming out, goes and buy an electric vehicle, feels very clean. But you can see in the background with electric vehicle, if it's dependent mostly on the fossil fuel based energy, the emissions will start going up there too. Electric vehicle, you can correct me if I'm wrong, but what I have seen from some of those literature out there, the typical electric vehicle, if for around 250 to 300 kilometers, it consumes amount 25 times of a big refrigerator at home. So these days refrigerators are big, isn't it? We have around like 400 plus liters, the double door ones, top bottom or bottom top, depending on where. And they're quite those big refrigerators. You need 25 refrigerators worth of energy to make the electric vehicle travel around 250 to 300 kilometers. And then making of the electric vehicle, making of the batteries, life of the batteries. So of course there is a lot of things that goes there which we need to take into consideration if you really want to find out real benefit of moving to that electric vehicle. So that's on just to highlight that. We already talked about this, so very quickly I'll just show you some like one or two examples here. So we do compilation and evaluation of input-output, environmental profile. ISO standard is there. We can use it for a variety of purposes. This is the process. We talked about that, goal, scope definition, inventory analysis, impact. Then from the raw material acquisition to material processing, manufacturer assembly, use and service, retirement, recovery, treatment, disposal. So we need data for each and every aspect. Each and every aspect, we need to get the data. We need material data, we need energy input, and we need to collect the waste coming out of gas, liquid, and solid waste coming out. So we have to get the material flow of the product component. So once you have the data, you can start using LCA the way we talked about that. How LCA got developed, we had talked earlier a little bit, that it started with 1969 Coca-Cola. They had this study, which was not actually LCA, but something similar to LCA, but then nothing happened until 1984. Not much thing happened. Of course, something might have happened, but not documented stuff. Then we have the EMPA environment came up with a packaging report, and we found that a lot of waste is being produced in part of packaging. So there was an interest to find out what is the negative impact of all this packaging. So that's when people started looking at this LCA stuff. Then CTEC, you saw that methodology earlier, which CTEC methodology, they come up with first workshop, and first European guideline came on eco-labeling. This International Journal for Life Cycle Assessment came, which is nowadays not that easy to get published there, and initially it was. Then the ISO standard came in late 90s, early 2000. Then EcoInvent Center, which is a center which kind of has a lot of databases together. And we do have access to EcoInvent. As you have access to EcoInvent through SimaPro software, if you have. But even if you don't have SimaPro software, in India, I get always confused between non-OECD and OECD, but whatever it is, we do have access. Academic institutions do have access to EcoInvent database. You just write an email to EcoInvent, and then they will ask for some proof that you are in an academic institution, and they will give you the license. But it's usually they give one license older. Whatever is the current one, you will get the one older because of that's. But that serves your many of the things that you will do. So that's not a big problem. And then you can use OpenLCA and other tools out there, which is there too. You don't have to buy LCA software to do LCA these days. Then UNEP came in. Then UNEP Lifecycle Initiative, CTAC all came together. Then in 2002, then European platform was launched. Then that international this LCD handbook came into. Social LCA guideline came in between as well. So that was there. So once you have, in terms of LCA, we talked about goal and scope, inventory analysis, impact assessment, and interpretation. So if inventory analysis, what is function, functional unit, what are boundaries, what data you need, and so on and so forth. So in terms of, see, if you want to compare, very simple comparison, just to so that you don't get like you at least remember like what we have been talking for last almost 2 hours now in terms of this. So it's saying, say if you want to compare two writing utensils for classroom use, one is your regular pencil, one is your mechanical pencil. So regular pencil, what you need your process flow diagram. It's starting from lumber forest, lumber mill, manufacturer, retailer, use, and end of life. So this is rubber, graphite, packaging, brass, and all those. And then for each one of them will get transported. So that's why T is there for transportation. So as simple as a regular pencil, wooden pencil, you see there's so much components of process flow diagram. So many things are there, which is required in process flow diagram. Similarly, if you use a mechanical, again, transportation is there. Mechanical is coming mostly from plastic based. So polyethylene, polypropylene, both are plastic polymers. Plastic is coming from oil. So from oil to the polyethylene, polypropylene, rubber, graphite, packaging. Many of these mechanical pencil also has a spring. Then you have the manufacturing of it, retailer, use, end of life, and all. So that's your stuff. But if you want to compare these two, say if you want to do an LCA to find out which one is actually better from an environmental point of view, should we use this mechanical pencil or should we buy and use our Natraj that we had? Nowadays that doesn't come. Natraj maybe business is down. And then I don't know whether you have seen Natraj with Chakka Marta tha, and then Natraj was Fir Hua champion. So anyway, so if you want to compare one mechanical pencil versus one wooden pencil, that's not a fair comparison. Because of course, mechanical pencil will have a higher carbon footprint. So, but we have to look at what is the function. Function is to compare, isn't it? Function is to write. Function is to write. That's what we use pen or pencil for, to write over it. So we can say function is writing. Functional unit could be 1 semester worth of writing. Like by using this versus that by 2 students who have similar writing. It's not that some people are taking only a few pages notes and someone sitting in the front bench and taking 10 pages of notes every day. Then also it will not be fair. So similar level of writing, so similar number of pages of writing with similar margin, similar spacing and all that. So that we have to have some sort of a fair comparison between the two. So that may require 10 wooden pencils versus maybe require 1 mechanical pencil, but you have to change the lead in there. And so those becomes your reference flow. Those becomes your reference flow in terms of in terms of your like in terms of the data collection. So that's your data collection will happen based on that. Then you have to get the data. So you get the energy data, materials data, labor data. Then you look at the output in terms of what is the product, what is the waste, what is the emissions, what is the co-product which is formed. So you get all those stuff. Then you do all the data collection, which I mentioned earlier too, like in terms of time-sensitive data, geographical regional data, best available data, consistency, reproducibility. In terms of data, we have to be really, it has to be precise data, consistency, reproducibility, QA, QC, quality assurance, quality control. Those are very, very important. And important even for any data collection that you do. In whatever experiments you will do as part of your research as well, those of you who are students in the audience, that's very important in terms of getting the good data. Then you take the data, you try to put it in terms of different impact categories: global warming potential, abiotic depletion, human toxicity potential, land use, eutrophication, acidification, and there are many more impact categories. You choose the ones, there are already predefined ones in the different impact method, or you can choose your own impact categories and do that too. And you can make, do that exercise as well. So once you get that, then you get all those information, you try to interpret. What is the purpose of all this data? So this example was there, but if you look at any product, what scientists can do, they can make recommendations for choices that are less impact. They can analyze a particular impact and also focus on a solution, try to come up with a solution to that. Industry or individuals can make closer look to how they can make a difference. Industry can say that, okay, let's focus on producing these products which has lesser environmental footprint. And with this, now the way the countries around the world is moving, there are taxes are going to come. Like in European Union, I think 2026, if I remember correctly, they will start a lot of taxes products based on their carbon footprint. So many of these products will not be sold, will be able to be sold in European Union. And that they have to do a lot of LCA exercise. And those LCA should be done with a methodology which is approved by the European Union. So of course, ISO standard will be okay. So that's where people are looking at those aspects. So we knowingly or unknowingly, people have to start making changes to that. So there are a lot of tools are available. We have CIMAPRO. We have been using it for almost last 10 years. That's what it comes with the eco-event data. With the data, it's still with the database, you have to collect a lot of primary data, and that can take months to run a simple model. There are LCA calculator is available, which is online free for 14 days. You can use it. OpenLCA, of course, it's an open source software. If you're used to any one of these software, you're okay. Or there are other softwares also out there which people are using too. So this was just a kind of, I would say, we try to cover in last nearly 2 years now. That was essentially what we cover on a 8-week course and 5 hours every week. So 40 hours worth of material I try to squeeze into 2 hours, and so that you can. But if those of you in online offline, if you are interested to learn more about it, this course is going to start on July 24th, and it ends on September 15th with the exam in September 24th. Enrollment is open right now. You can register and take this course, and for enrollment, the link is there. You can go to NPTEL SWAYAM web platform and just look this course. You search for sustainable engineering concept and life cycle, you will find the course. So that kind of brings us to the end of this session. I hope it was useful. And if there is any questions, we'll be more than happy to take it. And I have my contact information. Of course, most of you who have joined probably have my contact information already. But in case you want it, it's there. You can always get in touch. And if number has up, that's the easier way of getting in touch. So do we have any questions? It's in the chat. So I'll open the chat. Oh, only is there. So we can start from the bottom or from the top? From the top. Okay, so Upender Singh, he has a question in that how decarbonization can be linked with industry Are there any time duration for this of being profitable, or why big players of our country are not getting attracted to decarbonization? In fact, the big players are getting attracted to decarbonization. I will not say they are not getting attracted to decarbonization. Anything in the industry does not happen overnight, and will actually, and it should not happen overnight too, because there is a transition where things move in a transition. But yes, you may want to suggest that things may move faster than what we see, but it is there will be cares. Like even if you look at Reliance, they are investing so much on biofuels and different kind of stuff. Indian Oil is also doing quite a bit of what you will hear from 3 industry partners. I would you look at the like Indian Oil is one of the industry personnel from one of the GM from